What if I told you that everything we thought we knew about how the universe formed might be wrong? In December 2021, NASA launched the most powerful telescope ever built, the James Webb Space Telescope. $10 billion, 25 years of development, 1,000,000 miles from Earth. Its mission was simple: look back in time, see the earliest galaxies, confirm what we already knew. But within months of turning on, it broke physics, not metaphorically. The data came back, and senior astrophysicists, people who've spent 40 years studying the cosmos, went quiet. One of them, Dr. Alison Kirkpatrick from the University of Kansas, said something that still echoes in my mind. We're going to have to rewrite the textbooks. This isn't clickbait. This isn't speculation. This is NASA's official data. And today, I'm going to walk you through exactly what they found and why it's keeping scientists up at night. Before I show you what Webb discovered, I need you to understand something. When you look up at the night sky, really look on a clear night away from the city, you're not seeing the present. You're seeing the past. Light takes time to travel. The light from our sun, 8 minutes old by the time it hits your face. The light from the nearest star, Proxima Centauri, 4 years old. And that faint smudge you might see in the constellation of Andromeda? That's light that left 2.5 million years ago, before humans even existed. So telescopes aren't just cameras. They're time machines. And the James Webb Space Telescope can see further back than anything we've ever built. We're talking 13.5 billion years ago, just 300 million years after the Big Bang itself. Now, here's what we expected to see. According to our best models, Lambda CDM, the Standard Model of Cosmology, the early universe was chaos. Hot, dense, a soup of particles. Galaxies didn't exist yet. It took hundreds of millions of years for gravity to slowly pull matter together. First, small clumps. Then, over billions of years, those clumps merged into larger structures. Eventually, the grand spiral galaxies we see today. It was supposed to be slow, messy, gradual, like watching a city being built brick by brick over centuries. So when Webb pointed its golden mirrors at the earliest corners of the universe, we expected to see construction sites, scaffolding, chaos. What we found instead: skyscrapers, fully formed, gleaming, as if they'd been there all along. In July 2022, just 6 months after launch, the first deep-field images came back from Webb, and the astronomy community went into quiet panic. Here's the headline fact, the one thing I want you to remember from this entire video. Webb discovered galaxies that are too big, too bright, and too mature to exist that early in the universe. Let me break that down. One of the first major findings, published in Nature in February 2023, identified 6 candidate galaxies from just 500 to 700 million years after the Big Bang. That's incredibly early. The universe is 13.8 billion years old. This is like the first 5% of cosmic history. And yet, these galaxies contained as many stars as our Milky Way does today. Our Milky Way has had 13 billion years to accumulate 200 to 400 billion stars. These galaxies, they apparently did it in under 700 million years. That's not just surprising. By our current models, that's impossible. Dr. Joel Leha at Penn State, one of the lead researchers, called it universe-breaking. His exact words: the universe shouldn't have been able to make these galaxies in such a short time. And it gets stranger. Galaxy Jades, GSZ 13-0, confirmed as one of the most distant objects ever observed, existed just 320 million years after the Big Bang. It's not just old. It's structured, organized. It shows signs of chemical enrichment, meaning stars had already lived and died there. Stars that produce heavy elements take millions of years to form and explode. So how were those heavy elements already present? The math doesn't add up. Either our telescopes are wrong, which NASA has triple-checked, or our understanding of how the universe works is fundamentally incomplete. Okay, let's slow down, because I know this can get confusing. Imagine you're at a party. Someone tells you their 5-year-old child just graduated medical school. You'd laugh, right? You'd say that's impossible. Kids don't do that. They haven't had time. That's essentially what Webb found. Baby galaxies, cosmic toddlers, except they looked like fully grown adults. Massive, organized, way too developed for their age. So what does this actually mean? Let me give you 3 possibilities scientists are now seriously considering. Maybe stars formed faster than we thought. Perhaps in the early universe, conditions were different. Denser gas clouds, different physics. Stars ignited quicker and in greater numbers. If the first generation of stars, what we call population 3 stars, were more massive and burned hotter, they could have produced heavier elements faster, seeding galaxies more efficiently. We've never directly observed these primordial stars, but Webb might force us to rethink their role. Or maybe dark matter behaves differently than we assumed. 70% of the universe is something we've never seen. Dark matter. It doesn't emit light. It doesn't interact with normal matter except through gravity. Our models assume dark matter clumps slowly over time, pulling regular matter with it to form galaxies. But what if dark matter clumped faster in the early universe? What if there's something about its nature we've missed? Some physicists are now exploring warm dark matter models, or even more exotic ideas. Maybe dark matter isn't one thing. Maybe it's a family of particles we don't understand yet. And then there's the wild one. What if the universe is older than we think? Our estimate of 13.8 billion years comes from measuring the cosmic microwave background radiation, the afterglow of the Big Bang. But recently, there's been a growing tension in cosmology, something called the Hubble tension. Different methods of measuring the universe's expansion give different answers. Some scientists, like Dr. Rajendra Gupta at the University of Ottawa, have even proposed models where the universe could be nearly twice as old, 26 billion years. That's controversial. Most cosmologists don't accept it. But the fact that it's being seriously published and peer-reviewed tells you something. When your data breaks your models, you either fix the data or fix the model. Webb's data appears solid, so the models might have to change. Here's where I want you to really sit with this for a moment. We've spent decades building a story of the universe, a story that made sense. Big Bang, expansion, cooling, stars forming slowly, galaxies evolving over billions of years. It was elegant. It was mathematical. It was ours. And in less than 2 years, a single telescope may have proven that story incomplete. That doesn't mean we were wrong about everything. The Big Bang still happened. The cosmic microwave background is real. But the details, the timeline, the mechanics, something doesn't fit. And I think what makes this genuinely unsettling is the implication. If we were wrong about how galaxies form, something as fundamental as the building blocks of the cosmos, what else might we be wrong about? Dark energy, the fate of the universe, the possibility of life elsewhere. Here's something that keeps me up at night. In 2023, Webb also detected what appears to be complex organic molecules in the atmospheres of distant exoplanets. Carbon-rich compounds, building blocks of life. If galaxies formed faster than expected, if stars burned brighter sooner, if heavy elements were distributed earlier, that means the conditions for life could have existed far earlier than we ever imagined. Billions of years earlier. Life on Earth is 3.5 billion years old. But if habitable planets existed 12 billion years ago, then somewhere out there, civilizations could have risen and fallen 10 times over before our sun even ignited. We might not be early to the cosmic party. We might be catastrophically late. And those civilizations, if they existed, where are they now? The silence of the universe takes on a different meaning when you realize how much time has actually passed. But here's the thing, and I want to end on this before I ask you something. This isn't just scary. It's beautiful. Science is supposed to be surprised. That's the whole point. You make predictions. You test them. And when reality doesn't match your predictions, you don't hide. You don't deny. You marvel. Because that gap between expectation and reality, that's where discovery lives. Webb didn't just find pretty pictures. It found questions. Deep, fundamental questions that will reshape how we understand existence. And we're alive for it. You and me. Right now. 13 billion years of cosmic history, and we happen to exist at the exact moment when a telescope the size of a tennis court is rewriting the rules. If that doesn't give you chills, I don't know what will. Now, here's what NASA hasn't fully explained yet. Webb's primary mission is designed to last at least 10 years, potentially 20. We're only 2 years in. The galaxies I told you about, those were just the first batch. The appetizer. In 2024 and 2025, Webb is scheduled to conduct deeper surveys, longer exposures, looking at specific regions of space for hundreds of hours at a time. Scientists believe we might find even older, even more impossible structures. Some researchers are quietly whispering about something they call dark stars, theoretical objects powered by dark matter annihilation that could have seeded the first galaxies. Others are suggesting that supermassive black holes might have formed before galaxies, not after, which flips everything. And here's the open question nobody can answer yet. If galaxies formed this fast, this early, what started them? There's something missing from our models. A mechanism, a trigger, something that turbocharged cosmic evolution in the first few 100 million years. We don't know what it is, but Webb might be about to show us. And when it does, I'll be here to break it down for you. So if you're not subscribed yet, you know what to do. All right, I want to hear from you, because this discovery opens up some huge philosophical questions. If the universe is capable of building complex structures faster than we thought, if the conditions for life existed billions of years earlier than we assumed, what do you think that means for us? Do you find it hopeful? The idea that the cosmos is more dynamic, more alive, more capable than we imagined? Or does it unsettle you? The thought that we might have misunderstood something so fundamental about reality? Drop your answer in the comments. I read every single one. And the discussions on videos like this are always incredible. Also, I'm curious, what discovery do you think Webb will make next? Do you think we'll find direct evidence of life? Signs of ancient civilizations? Or something we can't even imagine yet? Let me know below. And if this video made you look up at the night sky a little differently, share it with someone who needs to feel that wonder too. Until next time, keep looking up. The universe has more to show us.